See today, disk management. Okay, managing disks. So in any hardware, when you purchase, it comes with some disks like floppy disk, storage, hard disk. Okay, like there are different disks. Here, how to manage your storage device. Managing storage device in the sense how to create partitions after the installation of your operating system. Okay, how to delete, how to convert a partition type, one type to another type, how to extend existing partition size from one size to another size, how to reduce, how to make file system. Okay, we'll see. Here we have a fdisk tool to manage this. Note down fdisk. Fdisk. Fdisk stands for fixed disk or format disk. Fixed. It stands for fixed disk or format disk. Okay. So this is the most commonly tool used in Linux to create new partitions, to delete, to move something like note down that point also. So using this tool, we can view, create, resize, delete, change, copy, and move partitions on a hard disk or hard drive or storage device. You can note any name, hard disk or hard drive or storage device. Okay. Okay. Next, note down. Fdisk allows us to create maximum of 4 new primary partitions. Fdisk allows us to create a maximum of 4 primary partitions and number of logical partitions. That means extended, and number of logical partitions. Logical in the sense extended partitions based on the size of the hard disk. Based on size of the hard disk. Right. To see the existing storage devices names information, to view fdisk space -L. To view or to list. To view or to list all existing storage partitions on your system. Okay, so you chose all available storage partitions, okay, and storage device names when you run fdisk-l command. We'll see now. So how to configure this? So we have only one storage device. Example, if you have a 500 GB, after the installation, if you want to create some partitions, required a free space. If there is no free space available, we can't create partitions. Whenever you create a new partition, so first we have to examine, is there any free space available on your storage device? If free space available, we can create with specific size. Okay. Say if you want to install more than one storage device, we can install. Okay, so in virtual environment also we can install. We can attach a number of storage devices into one machine. Okay, in physical environment, so if you want to install a storage device like normal home purpose laptops or desktops, so require a downtime. But in real time, not require any downtime. Directly we can attach number of storage devices to a server. Okay, right. See here, to attach a new storage device to your virtual machine, right click on your virtual machine, go to settings, hit your storage option, right? Okay, storage. Here already we have a one storage device. If you want to attach another storage device, click on this. But here required a downtime. First you have to power off the machine. If you want to attach new storage device, then go to this settings, select storage, click on SATA controller. Here it shows two options, right? 2 plus. The first one is optical drive. If you want to attach one more CD-ROM optical drive, we can click. So this one is for storage. Add hard disk. Click on that. Create new disk. Select the size. Right? So 8 GB, 16 GB, 32. This depends on. You can give any name for this, like A. See, dot VDI. Dot VDI, the name, virtual disk, right? Created, just attach it. Now power on the machine. So this machine is having two storage devices. On one storage device, already installed operating system. That space is used for some purpose. So the second storage device we installed for another purpose, to store application data or some backup purpose, right? Now power on the machine. Right, now run fdisk tool. Fdisk -l. It shows list of storage devices. On each storage device, the partitions information. See, when you run this, it shows detailed information about each and every storage device available. Disk name. What it shows name here? SDA /dev/SDA. So all devices information will be stored under dev directory. Okay. See, SDA is a storage device name. First storage device name. So here we have a SATA storage device type. That's why so it shows SDA. When you install IDE storage device, then it shows HDA, the name. Okay. Based on storage device type, so it shows device name is like, if it is SATA, it shows SDA. When you install more another one, SDB, second storage device, SDC, third storage device, right? Like so on. IDE, storage device type IDE, and it shows HDA, HDB, the storage device names, like, right? So SATA or SCSI, both shows it the names SDA, SDB, SDC. The same thing here it shows. The storage device type is SATA, right? So that's why it shows the first storage device name SDA, size of the storage device in MBs, same size in bytes, same size in sectors. Okay. So each sector equals to, one sector equals to how much size? 512 bytes. 512 bytes. Each sector equals to 512 bytes. Right? See here. Shows are not 512 bytes. One sector of, and the information, the partitions at SDA device. So we have SDA1 and SDA2 partitions. Okay. So next we have another storage device, SDB. The size of the storage device, the same size in bytes, same size in sectors. Right. So there is no partitions available on SDB storage device. Complete space is available. See, let me check. See here we have a SDA storage device with size 8 GB. Okay, the size in MB is 8589 MB. Okay, so how to see that whether size is available or not, free space is available or not? And this here we have a sectors, right? Okay, when you create a partition, so available sectors to some based on your specified size, some sectors will be allocated to a specific partition. See here, SDA storage device created, and the sector number started and ended with some specific size. After that, SDA2 storage partition created, sector selected from here to 16777215. What is the last sector here? So it means what? There is no free space available here. There is no free space available. So both are same, right? 215 here, 216. So complete sectors utilized. That means there is no free space available on this storage device. Okay. So here we have a free space 8 GB in SDB. To create partitions, fdisk space device name, on which storage device you want to create partitions. First we have to examine. So by using ls-l, select the free space available storage device. Okay. If you want to see a specific storage device information, just specify device name /dev/sdb. Only it shows specific storage device information. So if not specified, it shows all storage devices available on your session. Okay. Right. /dev/sdb. There is no free space, right? SDA. If you want to see that, SDA. Once you run this, you'll get a fdisk tool environment. So in fdisk tool, we have various commands to create partitions, to delete partition, to resize, to change, right? To alter partition table, to save. Okay, without saving, we can quit from that fdisk environment. So for that, we have a m command here. Just run m command at fdisk environment. It shows list of available commands. List of available commands in that environment. As per requirement, use the command name. So to create new partition, n, add a new partition. M, print this menu. Print this menu in the sense list commands. Hyphen this one p command. Print the partition table. Partition table in the sense how many partitions are available on this storage device. If you want to see, just run p command. It prints partition table information. Next, q command. Quit without saving changes. Right. W, write table to disk and exit. To verify the partition table, v. Okay. And so we have L command, list known partition types. T option, change a partition system ID. That means we can change partition one type to another type using T. Like there are different commands. Right. Now run P. It prints partition table information. Print it. So in SDA storage device, there are two partitions. slash dev slash SDA1 slash dev slash SDA2 and its size, right? Got it? See, try to create partition. N is the command to create partition. See what it shows after executing N command: partition type. So primary or extended. See, fdisk allows us to create maximum of 4 primary partitions and number of logical partitions. To install operating system required a primary partition. We can't install operating system on logical partition. That means on extended partition, right? See, we have a storage device 1 TB or 2 TB. So if you want to create more than 4 partitions for your purpose, okay, so we can't create more than 4 partitions when you create a 4 primary partitions. So when you're trying to create a 5th partition, so it won't accept. Okay, so maximum of 4 we can create. So if you want to create more than 4, then create 1 partition as a extended one with remaining space. So from that extended partition, we can create 11 logical partitions. 11 logical partitions, right? So that means 3 storage partitions, primary, 1 extended we have to create. So extended partition with available space, complete space. From this extended, create a logical partitions. So that too, it allows 11 logical partitions from extended, right? See which partition you want to create. So use that symbol. By default, it shows P, primary partition. If you want to create extended, then type E here, run. Okay. Select the default one, primary. See what it shows: use the default response P. The partition number 3 and 4. Already 1 and 2 is used, right? So enter. What it says: no free sectors available. See here, there is no free space. If free space is available, it shows starting sector number. Okay, we have to specify size. Once you specify size in sectors or in MBs, partition will be created. See, once you created a partition, to save that information to partition table, W, save and quit from that. No, not create. No extended. 0 extended in the sense no extended partitions here. 0 means no extended partitions available here. 2 primary partitions created. So available 2 partitions primary we can create. 0 extended we created. If you created any extended partition, it shows number 1. Right? Like W to save and quit. Right? So without saving, if you want to quit from that fdisk environment, Q. Okay. SDP. No, not the space. It shows you can able to create more, 2 partitions primary, but there is no free space. If you have a free space, then only we can create. Right? SDB run P. What is P command? It prints partition table information. Is there any partitions here? No. Complete sectors available. Now run N command to add a new partition. See what it shows: 0 primary partitions. There are no partitions available in SDB. 0 extended, 4 free. Now run. Select the default one, primary. Select the default one, partition 1. See here, it shows first sector. So no need to enter any value. Select the default sector number. Now here you can specify size in sectors or in MBs, KBs, GBs. Okay. See for that, plus size 1G. 1 GB partition will be created. If you want to create 2 GB, 2 G. Okay, like 100 GB partitions, 200 GB partition. So you have more space on your storage device. Here we have only 8 GB storage device. Okay, see, just create 2 GB partition, run partition 1 of type Linux of size 2 GB is set. 2 GB is set. So if you want to see that partition table information, P created SDB1, first partition created in SDB storage device. The partition name is SDB1 with size 2 GB. We created with size 2 GB created. The default partition type is Linux. Linux is the default partition type. System ID is 83. System ID is 83. The partition hex code. Partition hex code 83. Here we have a different list of hex codes. Okay. So if you want to convert this partition SDB1 from Linux to swap, RAID, LVM, there are different hex codes, different partition types. We can convert. See, for that, a list of hex codes available. If you want to see that list of hex codes, run L command. Here we have different hex codes. See, 83 Linux, 82 Linux swap, okay, extended 85 Linux extended, which shows 5 extended partition, 80 Linux LBM. There are different hex codes. Okay, so depends on your requirement. Create a partition first, then convert that partition to desired hex code. Right? See, now create another partition, N. Select the default one. Now specify the size 1G plus 1G. Created second partition? Yes, created. Create another partition. Three partitions created. 3 are primary partitions. Now create another partition. So by default it shows extended. So if you want to create a primary, enter P and specify the size. Successfully 4 primary partitions created. Got it? See, here we have available free space in our storage device. Try to create another partition. So what it says, if you want to create more than 4 partitions, you must replace a primary partition with an extended partition first. Okay, so then delete one primary partition, this one, last one delete. How to delete? So we have a command D to delete. D, then it will ask the partition number. What is the partition number? 4. SDB is a device name, 4 is the partition number. Deleted. Removed or not? Yes. Now create a new partition, extended. So create extended partition with available free space. Now our storage device contains more space, right? So select the complete storage device space to extend it. So don't enter any value. Let's run. Enter default value. So now one extended partition is created. What is the extended partition? System ID 5. Successfully created, right? Now we can able to create number of logical partitions from extended. Create a new partition. Okay, adding logical partition 5. Same plus 1G. Created Linux partition. The default partition type is Linux, right? Successfully created. SDB 5, like 11. That means what? Total 4 plus 11, 15 partitions we can able to make on one storage device. Only 15 partitions we can create. 15 partitions we can create on any one storage device. Fine. Now save this information. W. The partition table has been altered. Right. Successfully here created partitions, but we have to update the same information into your kernel file system. Kernel file system table. Say otherwise, for kernel file system table still use the old partition table information. Old partition table information. We have to update newly created partitions information to kernel now. So for that we have to reboot the machine. So instead of rebooting, we have a commands like partprobe, partex or kpartex. Without rebooting machine, we can update newly created partitions information to kernel file system. See, partprobe. Then only it allows us to make file system. It recognizes partprobe. Without rebooting server, to update partition table information to kernel partprobe. So this command will not work in 6 environment. Okay, so to update this partition table information to kernel in RHEL6 partex space -a, a specific device name, or directly we can run SDB. Okay, partex space -a. And we have one more command like kpartex. Kpartex. So this command we can use at RHEL7 environment instead of partprobe also. Okay, partprobe. Right, successfully updated newly created partitions information to kernel by executing partprobe command. Right, now how to access this created partitions? Successfully we created SDA1, SDB1, SDB2, SDB3, like. Now how to access SDB1 partition to store information into that? So for that, first we have to make file system. Okay, to store information into any storage device, first we have to make file system on that. So then file system, it allows us to organize data into files into directories, right? So we can create, we can delete, we can modify, we can move. If there is no file system, we can't do these operations on any storage device, right? So for that we have a mkfs command to make file system. Mkfs dot file system type. File system type. Our Linux operating system supports various file system types. So ext, xfs, like. So in ext we have a ext2, ext3, ext4 versions. XFS like BTRFS. There are different file systems. VFAT. Right. Now make file system with ext4. ext4 file system. Okay, means create ext4 file system on one storage device, ext4. So there are some limitations, I'll tell you that. mkfs.ext4/dev/sdb1, that's storage partition name. Successfully ext4 file system created on SDB1 partition. Right. Yes. No, there is no file system. Just we created a raw partition. So after that we have to create a file system. Right. To make file system on another one, SDB2. So we can make different file system on different partitions. XFS, mkfs.xfs created, right? Successfully created file system on newly created partitions. Then how to access those? So to access those partitions required a mount point. So mount point is a name to access storage partition or any file system, right? So in its devices, mount point. First create a mount point name, that means one directory. /dev data. Here I'm going to create a mount point name like data. Already exists. Okay. Another one is backup. Created two mount points. Now mount SDB1 storage partition on data mount point. Once you mounted SDB1 on /data mount point, okay, when you access data directory in the file system, so when you write something into that, files information will be stored into SDB1 partition blocks. SDB1 storage partition blocks. So to mount storage partition on mount point in the file system, we have a mount command. Mounting. Mount space partition name /sdata mounted. If you want to check whether the file system is mounted on data or not, so we have a df command. Df disk file system to view the disk file system information. So it shows mounted file systems information. SDB1 is mounted on data. So it is a field, last field, mounted on file system name. Once you make file system on any storage device, also known as a file system, right? The size of the partition, used, available, and the used size in percentage, and the partition is mounted on the mount point name it shows. SDB1 successfully mounted. Or we can run mount command. Mount also it shows all mounted, temporary or permanent mounted. Mount point names it shows all mount points available in your Linux box. It shows what it shows in the last field. SDB1 on data type, the file system type ext4. Okay. So if you want to see that file system type information, th, when you run this df command, it shows mounted file systems information with its file system type. When you use -T H option, H means human readable format, T it prints type, file system type. This is SDB1. On SDB1 created ext4 file system, and size, used, available, same, mount point name. Got it? See, mount, we can redirect results to grep with the help of pipe. We can search for a partition name or a mount point name, right? We can see or not. So whether the partition is mounted on successfully or not. Like there are different ways to check. So using df or using mount command. Okay, successfully mounted. Now mount another one. Mount space /dev /sdb2/backup. What it shows? Successfully mounted or not? Yes. /dev /sdb2 file system type on XFS size backup. Right. Now access data directory slash data, the mount point name. So it contains nothing. Is a default directory lossless mount. Okay. Create file now. Cat file1 hello sdb1 created successfully. Once you've created file under data directory, the file and its information, data, everything will be stored at which storage partition? SDB1. SDB1 storage partition, because SDB1 is mounted on data directory. It's a mount point name to access that storage partition. Right. Next, access backup. Access backup. It contains nothing. Create file. File2. Hello SDB2. Created. Same thing. So under backup, once you created files, if you updated anything, if you copied files into this backup, the information will be stored under SDB2 storage partition blocks. SDB2 storage partition blocks. Right? Fine. If you unmount it, what will happen? Mount point will be disconnected. If you unmount it, mount point will be disconnected. So disconnect the mount point. So how to disconnect? So how to unmount? We have a umount command. Using umount, we can unmount. Just specify a mount point name or partition name, we can unmount. Let me check. Unmounted? Yes. Is there any partition number here? No, right? SDB1 successfully unmounted. Now access data. See the result. It contains nothing. But we created file, right? File1. Where is that file? File is stored at SDB1 partition. So there is a storage blocks, right? So creating partitions in the sense number of blocks here allocated to a specific number. Okay. So dividing some section of blocks into one partition, some section of blocks into one partition. Okay. On your storage device. If you created files now here, Apple, hello data. What will happen? File created Apple, but this file is stored at which storage blocks? SDB2. No. Data directory is created on which partition? SDB1. Root partition. Slash, right? What is slash? Root partition. First we created mount point name under root partition. That means what? Data directory information stored into root partition. Once you mounted SDB1 on data, whenever you create a files under data, the same files will be stored into SDB1 after mounting. Here unmounted. After unmounting, if you created files, the same files will be stored into root partition. That means the partition created under which partition? So here we created the directory under root. What is the directory name? Data. df-th. What is the first one? This one. This partition. What is mounted on? Slash. So basically the partition name is SDA1 or SDA2. Okay. So here created logical partition LVM. That's why it shows the names CL-root. Okay. Otherwise it shows device name SDA2. Okay. SDA1 is a boot partition. SDA1 is mounted on boot. So this SDA2 is mounted on root. So under root we created data directory. Under data we created some files and the file name like apple. The file is stored into root partition storage blocks. Root partition storage blocks. Right. So we have a SDB1 storage device. Sorry, SDB storage device. In that we have a SDB1 storage partition. Once you mounted SDB1 storage partition on data, okay, let me check what will happen. Mount /dev /sdb1 /data. Data directory is under root file system. So before mounting, we created one file, apple. The file stored into root file system, root partition. Right. Now here mounted SDB1 on data directory. Now access data. Successfully accessed. If you created any files or if you copied files into data directory now, the files will be stored into SDB1 storage partition. SDB1 storage partition. So not into SDA2 partition. SDA2 partition. Right? That is different storage device partition. This is different storage partition. Just using this name, we are accessing physical storage partition in the file system. Orange. So previously we created one file, file1. Now we created orange. Okay. File1, it contains information. Hello SDB1. SDB1, right? Now unmount. Let me check the file information. Now access data after unmounting. It shows apple. Just after. Once you mounted any storage partition on any mount point name, when you access mount point name, so it shows information available on mounted file system. Mounted file system. Not previously created files under the directory. Here there is no data loss. Still we have a information on storage blocks. To access that, use different mount points or same mount point. Right? I didn't get you. Yes, yes. See, no, data won't be moved. So here we have a SDA storage device, SDB storage devices. So here created partitions like SDA1, SDA2, something. So SDA2 is mounted on slash and SDA is mounted on, one is mounted on boot. If you created files under boot directory, what will happen? The files information will be stored into SDA1 storage blocks, the partition storage blocks. So if you created files under slash, the files will be created under, the information will be stored into SDA2 storage blocks. So here we created a directory called data. So data information will be stored into SDA2 actually. So but there is another storage device, have a SDB, created SDB1 partition and SDB2 partitions like. To access these partitions from user space required a mount point names, same like here. So for that, here I am using this name as a mount point for this to access. But already created under SDA2. Okay, see, once you mounted this SDB1 on data directory, okay, mount point, when you access data, we can see whatever the files under SDB1. When you create files under data, the files will be stored into SDB1 after mounting. If not mounted, still we can see whatever the files under data directory which is stored SDB2. Right? Like the same thing, we can use data as a mount point or any other mount points. Okay. No, there is no data loss. So we can use another mount point name to access the storage partition, right? Say create mkdir, another storage partition. Say anything dir1. Oh, dir1 already there. Okay. Use mount point / mount / def / sdb1 / dir1. Mounted or not? Now to access sdb1, use dir1 directory. dir-th. sdb1 is mounted on dir1. When you access dir1, so whatever the files under sdb1, we can see that. File 1 orange, that is what we created right previously. After mounting sdb1 on data, we accessed the data directory and created file names like file1 and orange. Unmounted, again we mounted sdb1 on different mount point called dir1. Once you access dir1, still it shows the same information. Is correct or not? Just using name, we are accessing the storage partition to create files into that, to copy, to delete. Yeah, we can manage anything. Okay. See, once you mounted the file system on mount point using mount command, the mount point is not permanent. Mount point is not permanent. To make it permanent, we have to add this information into file system table. So we have a file system table. So there is a configuration file. We have to add into that. For that, edit the file /def etc fs tab file system table file. To make it permanent, mount point. Edit. Go to last line. Add information here. Your partition name. Partition mounted on mount point name. File system you created on that. Then permissions. Last, dump process and fsck information we have to specify. See, /dev /sdb1 device name, storage partition name. So instead of storage partition, we can use UUID of the storage partition here. We can specify label also. We can create labels. Instead of device names, we can specify a label. Okay, or directly you can specify a partition name. No problem. See, /dev /sdb1 mount on data or any other mount point. So permanent mount point. Data is now permanent mount point for sdb1 to access. Then file system. What is the file system we created on that? ext4. The file system type we have to specify. Then, sorry. Okay, that's it. File system type. Then in the fourth field, we have to specify permissions information. DEFAULTS, defaults. Permissions in the sense. So read, write, read only, and we can apply ACLs also here. Quota system. Okay, quotas. So there are different permissions we can set. When you write defaults, default permissions will be applied. Default permissions will be applied. So after this, we have to specify option 0, 0. First 0 specifies dump process. So file system backup, dump process. So at the time of booting, if you want to take your file system backup, okay, so then enable dump process. To enable dump process, instead of 0, specify 1. Okay. Last one is FSCK, file system consistency check. File system consistency check. See, once you reboot the machine, when power on the machine, there is some process, right, to boot the machine. We have a BIOS wake ups, it performs some something, and then it executes MBR. MBR executes grub. So then it grub executes what? Operating system. It loads, right? Bootloader. Grub is a bootloader name. It loads operating system. So operating system, what it does first, it mounts your file system as read only, then read write. See, whatever the file system names available in FS tab, it is trying to mount. It is trying to mount on desired mount point names. So here specified a file system name SDB1 and mount point name is like this. Okay, when power on the machine, operating system is trying to mount this partition on data. Once successfully mounted, during this process, if you want to check any file system read errors, okay, so then enable this last option 0 instead of 0, 1 or 2 you can specify, 1 or 2 you can specify. Once you enable, so during the boot process, so you'll search for the check for the file system read errors. If something went wrong at file system end, so it shows the information, then machine will goes to maintenance mode, right? Say to enable or disable, we can disable. The same thing repeat for another partition. /dev /sdb2. What is file system we created? XFS. That's it. Okay, you have to remember, sometimes in interview interviewer asks like what is the last two fields in FS tab entry. So what are the last two fields? Last two fields in the sense dump process FSCK. So how many fields are here? 1, 2, 3, 4, 5 and 6. 6 fields. What is first field? Partition name or partition label UID. Second, mount point name. Third one, file system. Fourth one, permissions. And fifth one is dump process. And the last option is FSCK, file system consistency check field. Okay. To enable or disable, instead of zeros, specify 1 or 2. Right? Like we have to add to make it mount point permanent. Now across the reboots, automatically the file system will be mounted on whatever the mount point name we specified. If not specified information into this, every time once you rebooted the machine, every time we have to mount the partition manually on mount point using mount command. Okay, right? So have any questions up to here? No, there is no data loss till we have a storage device, right? So data is available at storage device. To access that, so required a name at user space. So because the user can't communicate directly with the hardware. Yeah, we can see. Yes, any user can see. So that is depends on permissions user can access. So if you allow read access only, they can read. So if you allow read write, they can read and write. Right? Now we'll see how to create swap partition. This is how to create a normal traditional Linux partitions. Yes, we have different commands. We'll see that. Right? See, now how to create a swap partition. The same process. Select this first before going to create a swap partition. Examine the storage devices. Examine the storage devices. Select the free space available storage device. If you want to create a partition, require a free space. So for that we have to run fdisk. So same process. Select the device name /dev /sdb. Print. Okay. So delete the partitions. Fifth one. Okay, now we have SDB3. Delete this one also. Deleted. Right. So to create a swap partition, same process. Why? We need to create a swap partition. Is there any specific requirements? What is swap? Okay, swap acts like a virtual memory. Virtual memory, when amount of physical memory goes full. Physical memory in the sense RAM. Amount of RAM goes full, operating system will use swap space. Swap space. So for that we have to create a swap partition. Swap partition is created based on RAM size. Created based on RAM size. See, if you have a 1 GB RAM, so create 1 into 2 GB swap partition. So you have a 2 GB RAM, 2 into 2, 4 GB swap partition. So you have a 3 GB, 3 plus 2, 5 GB, 4 GB RAM, 4 plus 2, 6 GB, like, and so on. Right? So depends on RAM size. You have to create a partitions, swap partitions. Okay. Right. See, now when amount of physical memory goes full, all inactive pages from physical memory to swap area will be swapped automatically your operating system. That means all inactive processes. The process is running in the background, but not in active state. Not in active state. So those pages will be swapped from RAM area to swap area. Swap area. Okay. So then those inactive process will be run from the swap area, which is created dedicatedly on the storage device. Storage device. So once those process moved from RAM to swap, so amount of physical memory will be free, right? So then when it required the RAM memory, it allocates for a new process or existing process, your operating system. Okay. See, now we have a RAM 1 GB, or how to check RAM size? How to check RAM size? How to check? We have a free command, right? Using free, we can see swap memory size, RAM memory size, total memory size. What is the total size? 1 GB approximately, 992 MB, and swap 819 used, available. Shows, right? So based on this, we have to create. See, during the installation process, any operating system on hardware based on the RAM, so at the time some partition will be created. Okay, so after installation, few months later, if you upgraded RAM size from 4 GB to 8 GB, that means extended. If you extended 4 GB to 8 GB, based on this 8 GB, we have to extend swap also. So you have a 4 GB machine, you created based on this 6 GB swap partition. So few months later, so there is a requirement to extend this RAM size for good performance. Okay, you extended 4 GB to 8 GB physical memory size. Based on this physical memory size 8 GB, we have to extend swap partition size also. Okay, so 6 to how much size? 10 G. 6 GB to 10 GB we have to extend. That means, so 4 GB partition we have to create. 4 GB swap partition we have to create. See, fdisk /dev /sdb1 print. Now create a new partition with size. Select, specify 1 G. Then I'm going to create a 1 GB swap partition. Successfully here created one Linux partition. Now we have to enable swap on this Linux. So how to enable? We have a list of Xcodes. Run L, search for the Xcode related to Linux swap. What is this? 82. Yes. So we have a T command to change type of the partition. Run T, select the partition, which partition you want to convert from Linux to swap 3, then enter Xcode related to that 82. Change your type of partition Linux to Linux swap. Successfully changed or not? Yes, right? Print. Linux partition now changed from Linux to Linux swap. Successfully we created swap enabled partition. Save. Run. Path to probe. What it shows here? Warning. Rereading the partition table failed. Something. So warning message. The kernel still use the old table. The new table will be used at the next reboot or after you run path to probe or kparsecs. It shows same thing, right? Just run path to probe. Successfully updated this information. We successfully created swap partition. Now we have to make file system. So what file system we have to make? Swap file system, not actual file systems like ext4 or xfs. Like we have to make swap file system. To make swap file system on swap partition, mkswap is the command. Mkswap partition number sdb3 mkswap. Successfully created file system. Now we have to mount. We have to mount this swap partition. So how to mount? So we have a command swap on. Using swap on command, we can enable swap partition. We can enable swap partition, swap on. So before going to on this partition, check the existing swap size, 819 MB. 819 MB swap size. Now enable swap on newly created swap partition /dev/sdb3. Run free -h. Extended or not? Extended, right? See, 819 MB to 1.8 GB. Successfully enabled. That's it. See, once you enabled the swap partition using swap on, so this is also not a permanent mount point. So to make it permanent, we have to add this swap partition information into fstab file. So how to add? Edit vim/etc fstab. Okay. /dev/sdb3 mount point name. Here just specify a swap. File system also swap. Default 0 0. That's it. To add swap partition information, specify a swap partition name, mount point name swap, file system name also swap, then permissions defaults 0 0, dump process and fsck information. Okay, now across the reboot, automatically whatever the mount point names you specified, file system information we specified under fstab successfully mounted. Right, so this is how to create a swap partition. How to create a swap partition. Okay, see, if you have a free space, we can create a swap partition. If there is no free space available, but there is a requirement to extend swap. So you have to read. Yeah, you can use more, less, head, any command, right, to read that. Right, or we can run df space hyphen th, the same thing it shows, right? Mounted file system information, right? So here successfully created swap partition. So when it required, because free space available at our storage device. If there is no free space available to create new partitions, so complete storage space utilized for existing partitions. So then what is the solution? So here we have a swap file concept. We can create a swap file. So file we can create anywhere in the file system, right? Then make file system on newly created file. So to create a file with specific size, we have a dd command. We can create a file with specific size, 1 GB, 2 GB, 3 GB like. See, used cat, touch, we created files with 0 bytes, not with specific size. In using VI also, nano also. But we have a dd command. Using dd, we can create a file with specific size. So very dangerous command. dd stands for data duplicator. Using this tool, we can clone your storage device, one storage device into another storage device. We can take backups, we can restore. But while using this, make sure the input file path and output file path. Instead of specifying output file path, you specify it as input file as output file as input file. Complete data will be lost. Okay, right. See, now create a file with specific size. dd space input file equals to. So we have a special storage, special devices like 0. Okay, so it always reads null streams. It always writes null streams. The special device we have, we'll see that /dev 0, we have /dev /null. There are false. There are different special devices. We'll discuss that later. Just understand. So from this, I'm going to create a file with output file path. Where you want to create file, under which partition or under which directory. So here I'm going to create under root partition. Just specify name swap file. You can specify any name. For my understanding purpose, specify swap file. Then specify the size. BS blocks, block size 1 MB. Count equals to 1024. 1 MB into 1024 equals to 1 GB. Here I am going to create 1 GB file. If you want to create 2 GB file, then increase the count. Increase the count. The size, block size, we can specify in KBs, bytes, GBs, MBs. Okay, so based on this value, we have to specify the count number. Okay, which is equals to 1 GB, 2 GB. That is depends on your requirement. Run this command. Successfully 1 GB file is created. Successfully 1 GB file is created. If you want to see that, ls-lh/swap file. But it shows size. So we have a du command, right? Disk usage. We can view that information. What it shows in size 1 GB. You can see the file size using du or ls-lh. Right? Successfully created. Now make file system on that. mkswap /swap file. mkswap space swap file. Successfully swap file system created on swap file. Now on that swap file, swap on /swap file. Sorry. Right, now run free command, free-h. Check the size. Before it's 1.8 GB. Now after enabling swap file with 1 GB, 2.8 GB. Extended or not? Even though free space not available to create new partition at your storage device. If you want to extend swap memory, we can extend by creating swap file. So with dd command, then make enable. The same thing, to make it permanent, this we have to add this information into fs tab. So vim /etc fs tab / swap file name. Here we have to specify swap file. Then mount point name, file system name. That's it. To make it permanent. This is how to create swap partition and swap file when it required. Swap space only used for when amount of physical memory goes full. Okay, so your operating system automatically will move all inactive process to swap area. Okay, see here we created a swap partition with specific size as 1 GB. That 1 GB storage partition we can't utilize for other purpose, like to store some files into that, to create files into that. So the space is dedicatedly allocated for the virtual memory purpose. Okay, virtual memory purpose. So this is how to make file system, how to create partitions in Linux. Okay, see here the swap, once you create it, so there is a swapiness value, kernel parameter. So based on that kernel parameter, your operating system will use physical memory or swap memory based on the priority. So there is a value between swapiness value 1 to 100. Swapiness value 1 to 100. So when you specify a low value, like means less than 50, it avoids as much as utilizing RAM memory. Okay, so when you allocate, so more than 50, I mean 50 value, 60, 70, 65, like swapiness value, so it avoids RAM memory, it utilizes swap memory. So when you allocate less than 50, 45, 40, 30, it avoids swap memory utilization. Utilize as much as RAM memory. See, so for that, so there is a file like /etc /sysctl.conf sysctl.conf. So here we have to specify the module, I mean kernel parameter information, vm.swapiness equals to the value. Based on swapiness value, so operating system will utilize either RAM memory or swap memory. Okay. Okay. See, note down what is swapiness. Swapiness. So swapiness is a kernel parameter. Swapiness is a kernel parameter that controls the priority of the system. It controls the priority of the system, swaps data out of memory to the swap space. Priority of system swaps data out of memory to the swap space. Data out of memory to the swap space. Okay. A low swapiness value causes the kernel A low swappiness value causes the kernel to avoid swapping. Kernel to avoid swapping, comma, a higher swappiness value causes the kernel to try to use swap space. A higher value causes the kernel to try to use the swap space. The kernel to try to use the swap space. So this value between 0 to 100, not 1 to 100, 0 to 100. Swappiness value. This value between 0 to 100, and the default value is 60. Right. So low value causes, what will happen? It avoids swap space as much as RAM it utilizes. So higher value causes, it avoids RAM as much as swap it utilizes. Right. So note down 0. A swappiness value 0. A swappiness value 0 means avoid swap as much as possible and only use RAM. A swappiness value of 0 means avoid swap as much as possible and only use RAM. A swappiness value of 100 means avoid RAM as much as possible. Avoid RAM as much as possible and only use swap. Right. So note down. To change swappiness value or to change or set swappiness value, edit /etc/sysctl.conf file, sysctl.conf, and then add kernel parameter vm.swappiness /etc/sysctl.conf, and then add kernel parameter vm.swappiness. Okay, equals to swappiness value. Here you can specify 10, 20, 30, that is depends on your need, right? Got it? Have any questions up to here?
Hello?
Have any questions in risk management?
Hello? Hello?
Pardon? I didn't get you. It avoids RAM, so only it utilizes swap memory. Performance will be degraded. See, basically, higher value, swappiness value used above 50. That means high value for desktop environments. At server environments, we have to use low swappiness value for performance purpose. Okay. That is depends on it. We can modify the kernel parameter.
Hello? Suresh? Yeah, when we created, we have created only three families.
Three.
We have created
Only three. Four we can create. So if you want to create more than four partitions, then we have to create one partition as an extended one. One partition as extended one from this four. So then we can make from extended 11 logical partitions. Right. Let's see the overview. Using fdisk tool, we can manage storage devices. So before going to create partitions, just use fdisk-l tool. Once you run this, it shows all storage devices available and whatever the partitions are there in each storage device. It shows that name. Just understand that. That's it, right? You have a step-by-step commands. That is enough. /dev/sdb. If you want to create a partition, fdisk space -l /dev/sdb or sda sdc. Once you run this, you'll get a fdisk environment. Run m command for help. It shows list of available commands at fdisk environment. Right? For to create new partitions, use n. What it means? Add new partition. So then after executing this, it shows partition type, the parameter like partition type like primary, extended, ext, extended, e. It shows, but it shows default, default, default p. It shows something like. So if you want to create extended, just type e or then run. Okay, by default. Once you enter, it shows file system size. I mean partition size we have to specify. So here it shows select the starting sector. So no need to enter any value, just use the default one, then specify the size. Now we have to specify the size in MBs or in sectors. MBs, GBs, KBs we can specify. So if you want to create a 2 GB, 2G, or if you want to create a partition with in MBs 300 M, like we can create. Once you run, partition will be created. To check the partition table information, run p command. Run p command. If you want to create another partition, repeat the same steps. Right. To save this information, W. Once you run W command, so whatever the new partitions we created, the same information will be updated to partition table. Right. So after updating this information to partition table, again we have to update new partition table information to kernel file system kernel. So for that we have a command path_probe. So required a reboot to update that. So instead of rebooting, directly we can run. If that server is a production server, we can't reboot. Okay. See, for that just run path_probe or kpathx. So the same thing, if you want to execute, I mean create partitions, same steps in RHEL6 also, RHEL5 also. But to update this information to kernel, you have to use pathx -a device name. Example /dev/sdb. Once you've done this, we have to make file system mkfs.fs type. File system type. Say example mkfs.ext4 or mkfs dot xfs, we can use these commands. So here we have to specify partition name /dev /sdb1, sorry, /dev /sdb2, like mkfs. We can make file system. Once you make file system, to access this storage partition, we have to create a mount point. Create a mount point using mkdir data, then mount partition using mount command on mount point sdb1 /data. Okay, to check that information, just run mount command. The file system is mounted or not. Okay, so it shows the same information, or we can see that information by using mount space grep, or we can search, or we can /dev /sdb, sorry, sdb1, like, and we can search for that. Or else we have a df, disk file system usage. If you want to see statistics, disk file system statistics, it shows df -th. So T option, it shows file system type field. Type field, H means human readable format. So it also shows. Right. See, to make it mount point permanent, add information into fs tab /etc/fs tab. So here we have to specify first field partition name or UUID or partition label, then mount point name. Mount point name we have to specify, then fs type, file system type we have to specify, then permissions, then dump, and fsck information you have to specify. Example, /dev /sdb1, mount point name /data, file system ext4. Example, permissions. So default permissions we can apply defaults, or here defaults comma read only. If you specify like this, only we can read whatever the data inside that. Okay, we can't write into this storage partition. Then dump process. This is a file system backup process, and 0 fsck 0, file system consistency. Right. So to take file system backup, we have a command like dump for ext4 ext type file system. For xfs file system, xfs dump, we have a command to take file system backups. Just if you specify 0 space, automatically depends on file system, the command will be executed. So dump command for to take ext type file system backup. Okay, to restore ext type file system, dump file, restore is the command. Using restore, we'll see that in backup and recovery class. I will tell you. File system in the sense storage partitions. So complete entire. So if you want to take, along with operating system application data, if you want to take backup, you can create some dump file. You can store it somewhere. If something went wrong, we can restore it. Yeah. The file system corrupted, at file system end, if something went wrong, we can restore or we can recover. We have a different tools. Okay. Here for xfs dump is the command to take xfs file system. For to take xfs fs type. file system. To restore, xfs restore is the command. Okay, this is how to create partitions in Linux, how to make it permanent mount point, right? So for to create swap partition, we have to follow the same steps. So same thing, fdisk -l examine, then select the storage device as /dev/sdb or sda. Okay, so repeat the same steps. For to create new partitions, n specify the size. So after that we have to convert partition type Linux to Linux swap. So for that, so run l command, it shows list of hex codes, then find out the Linux swap partition hex code. So after that, run t command, so it will ask the partition number, enter partition number here. Okay, then it will ask xcode, so enter xcode, swap partition xcode 82. Okay, partition will be changed from Linux to Linux swap. So after that, save, then make run path probe command, then mkswap is the command to make swap file system, example /dev/sdb3. okay, so before going to enable swap partition, that means before going to mount, run -h, check the existing swap size, then use swap on command, enable sdb3, then run free space -h, it shows after extending that information. So to make it permanent this swap, we have to add information into fs tab. Okay, see if there is no free space available, so there is a requirement like to extend swap partition. So for that we have to create a swap file. See, we have a dd command, data duplicator or data destroyer, dd stands for. Using dd command, we can create a file with specific size. Input file /dev/0, output file equals to /swap file, block size equals to 1 M or 10 KB. You can specify. Based on this block size, we have to specify the count. Then file will be created with specific size. Then make swap file system mkswap. Once you make file system on that, then mount swap on. So before going to swap on, run free command, see the existing size, swap on /swap file, right? So to make it permanent, add this information into fs tab. So this is how to create Linux and swap and partition and swap file, right? So have any questions? So just note down about the /dev/0, this special device file. Note down on small note point, /dev/0. It accepts /dev/0 is a special device file, accepts and discards all input, accepts and discards all input, comma, produces a continuous stream of null bytes, accepts and discards all input, accepts and discards all input. produces a continuous stream of null bytes. That means 0 bytes. Produces a continuous stream of null bytes. It will accept input data. So automatically it will discards the data. That's why I created a file with this specific special device. So when it requires, operating system will use swap file. Okay. So when whatever the inactive process moved to this swap area, if that process goes live, I mean active state, automatically it will swap it from swap area to physical memory. Then the information will be released, discards whatever the information stored previously. Like there is another special device file /dev/null. Same, accepts and discards all input, comma, accepts and discards all input, comma, produces no output. Produces no output. So in brackets, note down. Always returns an end of file indication on a read. Always returns an end of file indication on a read. Read. Right. So try yourself to create partitions. Okay.